Okay, thank you very much, Martin. Just getting my side sorted out. So,
Yeah.
hello everybody. I'm Dan Warren. I work for Samsung Research in the UK, and what I'm going to talk to you today about is some of the work which we've been conducting within a European Commission project on 5G called 5G Vinnie. So I lead a team within Samsung Research UK, which is called Advanced Network Research. Up until probably 2018, we were focused primarily on 5G technologies across initially radio and then increasingly more end-to-end systems and including application of artificial intelligence in the core. Now we think 5G is a bit kind of 2020, and we're moving on to look at beyond 5G technologies and further into 6G. So our research focus at the moment is primarily around topics like Open RAN, application of end-to-end artificial intelligence, some work around MEC, which we've been working on with Smart Internet Lab at Bristol. And then also we do quite a lot of work within standards and also in regulation. So we have delegates at 3GPP, GSMA, GSA Spectrum Group. So we are, if you like, the European outpost of the much larger Samsung Research Organization hosted in Korea. But as I mentioned, today I'm going to talk about 5G Vinnie. So if I move on to my next slide, 5G Vinnie is what was referred to as an ICT 17 project. So within the work of the European Commission under 5G PPP, there was a number of different project calls within the third phase of that very large funding mechanism that was 5G PPP. The first call of the third phase was intended to build a lot of practical 5G facilities, which could then be used to demonstrate incremental value on top of that. So the focus of the third phase was primarily around demonstrating vertical industry integration, proving out 5G KPIs, and also to a certain extent, beginning to look at how 5G networks would interconnect with each other using a range of different interfaces, be that user plane, control plane, or even at the orchestration layer. So in defining what 5G Vinnie was going to do as one of those multi-site platforms that was going to be established in that first call, we wanted to do a number of things which were quite ambitious, including beginning to move towards a zero-touch orchestration model, starting to touch on that interworking and interoperability between individual facilities, actually validate some of the 5G KPIs and then demonstrate how they could be maintained and be used to enable vertical industries to do things which are outside of traditional communications. And then to look at how you can build that business ecosystem and start to understand what a business case outside of a traditional B2C model, which most operators move towards. So we had a consortium that was built of a large number of companies. And so we began by trying to map out exactly what it was that the different sites were going to do. So 8 sites were established, 4 which were considered to be main sites and were hosted by generally by operators. So the site in Norway is hosted by Telenor. The one in UK is hosted by BT at BT Labs. One in Spain hosted by Telefonica. And then the last one is at University of Patras in Greece. In addition to that, we also had 3 which were considered to be experimental. That was one hosted by Altis Labs in Portugal, one in Fraunhofer Institute in Germany, another one in Germany in Munich, which is hosted by Huawei. And then finally, a moving experimentation site. So we have integration with SES for satellite backhaul. And so there is an SES mobile site which roams around Europe and enables all kinds of interesting experiments to take place. So on the slide here, you can see the 20 partners that were involved. We've built a network on site with BT. So we are providing the equipment into the UK site at Martlesham. And in addition to us, there is also Nokia providing a service layer orchestrator on top of that network facility. We were part of the broader consortium as well. So I lead work package 1, which was defining the architecture for each of these facilities. And we put in place a number of architectural principles whereby we wanted a level of consistency to be available in each of the individual 5G labs. So there were some baseline requirements which were set into the architecture, mostly based on 3GPP standards from release 15, but also extending into some of the more optional elements of release 15 as well, so that we would end up with a common set of underlying technology which would be available at all 8 of the sites. And then there was scope within the definition of the architecture to allow each individual site to expand and extend beyond that architecture to do their own thing. So the architecture itself was pretty much a standard network architecture, in that there was a RAN domain, a core domain, and a transport domain, obviously a number of end user devices, and then built on top of that, because of the way that 5G architecture is built, there was a number of controllers which are tagged back into a MANO architecture and NFV, so that the idea being that we could orchestrate in the long term individual slices of networks with different quality of service and quality of experience metrics, and be able to have lots of different vertical industries which had different KPIs running parallel within one network. Sitting on top of that, there was a service orchestration layer, so service operations and management. And above that was the customer, which in this case would be considered to be somebody who was bringing devices on site to actually conduct an experiment. And within this, we had a principle around enabling people to essentially configure their experiment via a user interface into the service orchestrator, which would then allow them to design a specific slice entry in a slicing catalog and orchestrate VNFs back into the different domains directly. That in itself would be quite an advancement over the way that everything is currently being done. But then we also had this plan to expose east-west interfaces at the service orchestration layer, and also the MANO layer, which would mean that slices could be established across multiple sites. So taking that architecture and then extending it out into one with Intersite Interconnection, we had that ambition on the basis of those east-west interfaces, where you would have a degree of, if you like, real-time or active information exchange. So data passing between the MANO and service orchestration layers. Some passive information, so that would be more like the exchange of catalog information, so that profiles of slices that have been put in place in one facility could be ported into another. And then also this more control layer level of interaction with execution commands and requests passing between those interfaces. And all of those interfaces drew on standards. These interfaces aren't really defined to an extent in 3GPP, but a number of different standards organizations had defined these. So ETSI-NFV, ISG had defined a number of specs, SOL 002, SOL 003, and SOL 005. There's also a suite from the MEF, and there's been work on the interfaces of this type in the telemanagement forum as well. All of those interfaces were intended to be exposed by all sites, so that we would have this highly dynamic and very fluid 8-site ecosystem, where essentially any customer coming into one site could request resources to be provisioned for an end-to-end network slice across multiple other sites as well. And you could pick out the VNFs that you wanted to orchestrate into the network. So that then led us to this idea of customer ordering and automated provisioning, which drew heavily on, as mentioned, the ETSI NFV specs. So we looked at primarily using SOL 002, 003, and 005 for enabling all of this provisioning of different resources to take place. And then on top of that, we took the GSMA generic slice template, which is in a GSMA document NG116, which gives you a template to use to essentially spec out everything that you might need to describe within a slice. So it includes things which you would expect, like maximum and minimum throughputs, maximum tolerable delay, things around bit error rate. But then it also includes a whole range of other perhaps new KPIs around things like reliability, which previously hadn't necessarily been things that could be measured and certainly not guaranteed. And when you actually get into the detail of the GSMA GST and the NIST template, what you find is that there's huge amounts of optionality within there. So there's actually 38 different parameters which can be set within a generic slice template, and each one of those can take a whole range of different values. I mean, for example, the maximum throughput slice template field can take any value. So there are, literally infinite combinations. And so narrowing that field down, particularly when it comes to enabling a slice template to be ported from one network to the other, becomes quite important. And the net result was that we had to consider things like slice federation, both at the definition and the orchestration layer, and also how interoperability between different slices, which perhaps are provisioned in different networks for the same service but have subtly different slice templates, might take place. So the key takeaway from all of this is that not much of this works actually as you'd like it to, and perhaps that's, I've described a lot of interfaces and a lot of complexity and things which are not currently live within commercial networks. So perhaps it's not surprising that not all of this worked. What we found, and for the last 2 days, I've been on a 5G Vinnie virtual face-to-face meeting. We've actually found that a lot of this adaptability and flexibility, which we seem to be requiring in 5G networks, creates problems when it comes to perhaps more traditional things like roaming and interconnect. So when it comes to actually working out how to do all of this, we've really had to do some hard yards in terms of getting definitions in place. So the customer ordering system itself, so where the customer interfaces into the service orchestration layer, that has been built from scratch. It's bespoke, and as a result, it's not something which is off the shelf. It had an awful lot of integration exercises which needed to be done to make it operate on the different sites themselves. Each site had generally a different vendor or vendors implementing the network within those sites, and as a result, the interfaces towards the customer service ordering were different, and so the integration exercise was huge. In some places, it hasn't worked at all, but the overall ordering system itself, while the interface works, once you get into the service catalog, the service catalogs are different and can be formatted different. So there's a further integration exercise that needs to be taken into account there as well. The service orchestrator to Mano interface, SOL 005, was found to be well, pretty poorly defined within standards. So we had pretty much every vendor stating compliance against SOL 005. But what we found was that for the implementation of SOL 005 to be useful, you actually needed to do a lot of extensions on top of what was written in the standard. And those extensions to become operational tended to be proprietary. So we then had the exercise of doing further development to try and get the varying implementations that existed to comply with something which we were having to write from scratch, because the ETSI specs were not necessarily up to scratch, or in some cases had quite important pieces of functionality explicitly missing. The GSMA Nest definitions were, as I mentioned previously, highly flexible, but as a result, very difficult to share. So we had to find ways where that could be coordinated. You couldn't just expect the definition from a slice which looked roughly the same in one network to work with the other. And there's not direct protocol incompatibility issues, but certainly in terms of delivering KPIs consistently on an interconnect, there are some real issues with one network lining up with the other. There also needs to be a lot more exposure of what's available in network resources. So if you have an orchestrator in one facility which is trying to orchestrate resources in another network, it's not currently in the makeup of operators to expose what's going on within their network across the boundary. You will find out what's going on the interface, which is directly interconnecting, but you won't find out what's going on in terms of resources within the network itself once you go past the point of ingress and egress. And that's kind of a mindset issue as much as anything. So regardless of whether there's standards to expose that information, the exposure of it is considered to be quite commercially sensitive. And then for the east-west interoperability on 002 and 003, we actually ended up giving up on that because it was just not mature enough at this point to be implemented for the purposes that we were using. So whilst 005 wasn't great, it at least had been implemented in some networks because it could be internalized, but east-west interfaces at this stage were almost impossible. And that meant it's been hard to do even experimental implementation. So the attempts made at 002 and 003 were time-consuming before we gave up. 005 we've got working in some cases, but not all, and as a result, it required all of that additional development work on top. And then the generic slice template itself has all of this flexibility, which causes its own problems. So moving forwards towards something which isn't a small suite of experimental networks and looking at how this might translate into something which is commercially implementable, you have real problems in terms of how you're going to be able to either allow the provision of resources from one network to another, in which case you would essentially, if you think about an interconnect or a roaming situation, you would have the network that owns the customer or has the commercial relationship with the customer orchestrating resources into a network which doesn't know that orchestration is coming, and so doesn't necessarily have available resource or capability or bandwidth to serve the customer for the overall end-to-end service. Or the alternative is that you have slice federation, where you orchestrate between the two orchestrators, and then the orchestrator within the visited network or the destination network for an interconnect can tell the home network up front whether that resource is available, and then the slice can be ported as it is using the generic slice template into the visited or the destination network and orchestrated by that network's orchestrator. But that may result in a lot of slices or a lot of interconnections failing on the basis of lack of resource. So there's some real technical issues there, but I think also, and probably more fundamentally in the longer term, there's an awful lot of commercial requirements to be worked out here as well. So roaming and interconnect today is a source of major commercial negotiation. There's a lot of work on transit networks around arbitrage, but there's also quite huge amounts of time and effort put into forming and maintaining roaming and interconnect agreements. When you add in the idea that you might need lots and lots of different commercial terms or different agreements for different types of network slices across roaming and interconnect, then there's obviously a massive commercial gap there to making this kind of service available across the operator ecosystem that exists in the global telecommunications industry today. So just to give you an idea of what we actually did, within the UK facility, we implemented two phases of networks. The first build was a 5G non-standalone network built in 3.5 gigahertz using an LTE anchor band in 2.6. And on top of that, we also included the 5G task force definition of millimeter wave, so the one which we've deployed previously with Verizon Wireless in the US at 28 gigahertz. We include within that a fully virtualized core, virtualized RAN, and virtualized element management system. So for things like CU, DU, RU split, we already had an open CIPRI interface between the RU and the DU, which now in O-RAN parlance is moving towards 7-2X. And we also had open interfaces between the CU and the DU. In fact, the DU was implemented remotely from the CU. So as you'll see on the right-hand side, the DU is in the cabinet in the center of the box, and then the CU and all of the core network and all of the management systems are on a number of servers on the right-hand side. In fact, what we had there was an instance of the full commercial implementation of the Samsung network. On top of that, we had a number of issues that arose around this. So whilst this is a commercial network, there was no direct slicing available to us. We did some level of slicing based on access point name separation. So the more traditional way that devices connect into core networks. We had no SOL 005 interoperability at all. We're still working on that now. There's 4 more months of the project to go, and we're still trying to get that working. And we also had the problem that the next phase of European Commission funding was where vertical experimenters were requested to provide proposals through ICT 19 projects, and no ICT 9 projects chose to use the UK facility. This actually turned out to be quite a good thing for us, because it meant that we basically had our own playpen. So anybody that has come along to us with a proposal to use a 5G testbed, we've pretty much been able to say yes to. So we have a number of static millimeter wave CPEs for delivering high bandwidth over line of sight, but also with reflected coverage. Then we also have a number of SA handsets now available, which can be used as modems, and a number of USB dongles. And so we've been able to demonstrate actually quite a lot of vertical use cases across things like critical service. We've done social care, medical care. We've done some stuff on multicast and broadcast and video production, remote video production. So we've actually done quite a diverse set of use cases, and not been held up by some of the more complex levels of integration which were expected within the project as a whole. So just to round out, a few personal conclusions that I think are still things that the industry needs to address. Normally, the technology bit is easy. You know, the selling tech beyond the connections is usually quite hard. But on this occasion, we've made the technology really hard too. You know, so defining 4G, defining 3G, 2G, the technology was straightforward, and it was actually how it was implemented in the network, all of the commercialization around spectrum and interconnect and roaming and regulation, which causes some of the complexity. Here, I think we're going to run into increasing levels of complexity as 5G networks mature, and particularly if people try to implement network slicing both within a network and on an end-to-end basis. As a result of that, I think that it's clear at the moment that network slicing is not actually gaining much traction in commercial networks. So if you look at what most operators are selling, they're primarily focused on 5G as a B2B proposition, a B2C proposition. There's not much of that B2B pulling through. And so if network slicing is going to be a success, then you need to add on both the commercial business case around that, but also to implement an awful lot of technology which hasn't really been worked out yet. And on the flip side to that, what we're seeing now is that we can do things with vertical industries using essentially best effort. There's hasn't been a single one of the use cases which hasn't worked, and we've run multiple of the use cases parallel with quite high levels of bandwidth passing through the network, and all of that doesn't really cause us a problem. Where problems are more likely to arise is where you run into risk mitigation within networks, and I think that until people have got their head around exactly what the risk profile for selling a 5G connectivity service to somebody who has to have full reliability or an absolute guaranteed minimum bandwidth, and what the penalty clauses look like around that, we're going to see essentially anything which is about B2B business case still looking like it's a B2C plus model. I think that's my time. In fact, I've probably run over slightly, so I'll say thank you very much.
Okay. I missed the end bit there, but yeah, thanks very much, Dan, for that. That really interesting talk. And I think we've got one question already. That's from Christopher Christie. Are you able to briefly specify how 5G Vinnie supports network slicing as a fundamental 5G plus capability?
I can tell you how it should, and it may be that I kind of answered the question somewhere in the presentation as well. So it should work by essentially orchestrating orchestrating bits of the network or functionality, instances of VNFs, and the underlying transport network to provision dedicated resources to individual slices. So if you think about essentially the way that SVPNs work today, it's like SVPN on steroids. It's not just a partitioning, it's an absolute dedication of resource. But the model by which that happens, and how you manage lots of network slices being orchestrated into the network simultaneously, and then also the squeeze that takes place on the unsliced, if you like, the everybody else's best effort connectivity is a real challenge, because at some point you may run into the issue where if you don't get your network dimensioning correct, you've used up all of your best effort, and all of your traditional users end up with no service at all, or end up with very little throughput. So I think the challenge around this is actually going to be how lots and lots of network slices get managed simultaneously, and then what that implies about the overall network provisioning and the resource management which takes place using all of these interfaces which have been defined to a theoretical level, but without necessarily the practicality of experience of commercialization. So we're going to end up in a situation where we know roughly how it should work, but the practical reality of how it will work is still being worked out.
Yeah, well, that's where the engineers come in, isn't it? Sort out the reality. Okay, 100%. Well, I think we better leave it there and move on to our next speaker. Thanks very much, Dan.